Hi and good evening, everybody, and welcome to our 42nd How to Repair Pendulum Clocks Open Clock Club. And as always, super special warm welcome to anybody who's new here. This group was started to support beginners. This event was started to support beginners, and we've kind of had a bit of a journey over the last 42 weeks. And the usual caveat that this session is being recorded, and the recording will go on our YouTube channel, which is an archive. So if you are new and you want to catch up with what we've been doing, there are 42 hours, 42 hours. Not that I wish anybody to break their foot, but if you happen to break your foot and you are sat there with your foot open, can't do much, there you go. There's a couple of days worth of fun for you to have. Anyway, so what we've got this week is we've got our top 24 faults when we that you find with clocks. When we wrote our book, which is up here, How to Repair Pendulum Clocks, Volume 1, one bit of feedback from one of our customers was that there isn't a kind of overt fault finding section in that, and it's a good point actually. We may put that in our second book. I don't know. I suppose with the single train Enfield clock, the point is that if you go through the processes we described, there shouldn't be any faults. However, it's a really valid point. So I thought, what are the top kind of faults, perceived or otherwise, that people find when they're repairing clocks? So it'd be useful exercise and to get it written down to run through them. So that's what we're going to be doing tonight. But before that, a couple of things, one of which I've forgotten already. But the main excitement is that this mainspring winder has been donated by one of our regulars. So thank you very much for your generosity. And it's one of our Open Clock Club tool giveaways. So it's a dead simple thing to do. Just in the live chat, which is already up and running. I see we've got 42 hours of fun here. We've got Team Open Clock Club running the live chat. In the live chat, if you want to win this tool, we're going to post it free of charge anywhere in the world. Put the word mainspring winder, and then at the end of the program today, we will pull the names from a hat. For the people on Facebook who can't be here, or people who can't be here because they're doing other things, then we've given them opportunity through Facebook to enter as well. So they've already submitted their applications. So anyway, so nice kind of traditional style mainspring winder there, and we'll post it anywhere in the world. So there you go, mainspring winder. Very kind, mainspring winder. Well done, Mike. Get in there. So, gosh, it's like a machine here. Your name has already gone in the hat, which is not a hat, but anyway. So just before we start our list, little update from Facebook. We passed our thousandth member this week. We had like 20 applications today, so that's really cool. And we took the time to reflect on what is good about our Facebook group. Now, it's a lot, it isn't a lot of things, and I won't go into what it isn't, but what it is really is that, again, to support beginners, but work in progress. And yesterday was a really great example. We had Sam, who had been doing some work on making a minute wheel stud. We had Jeremy, who had been talking about a Dutch clock, which got Fyodor interested. Yeah, we had a really great day of work in progress posts. So thank you for keeping that going. Last week, we worked on our Fusey clock, and that's still running. Hasn't run a full week, which sounds bizarre because a full week has elapsed. And the reason it hasn't run a full week is that this room, the multifunction space, is also sometimes a kind of guest room for my daughter, who everything crossed is disappearing off to university next week. So she's been in and out. So with she's one of those tiresome people who can't sleep with a ticking clock in the room. Now, I'm one of those tiresome people that can't sleep without 20 ticking clocks actually running in the room, but that's another story. Anyway, the clocks run about 4 days, and I've kind of got it regulated. So I won't go over all ground. You can look at the archive footage thing from the last couple of weeks, but I fitted a new suspension spring. This suspension spring's quite thin. I think it was about 0.1 millimeters made the spring, and estimated the length. And this was the question, of course, how long is a spring? And this is one of the questions that rocks up the whole time on Facebook. I bought a clock, the suspension spring's either broken or missing, or the pendulum's missing. How long should it be? Well, there are kind of two questions there. So I estimated partly from the position of the crutch here in the slot, or the leader in the slot, and that was great. So the clock's fine. However, it was losing quite a lot to begin with. So you can see I've regulated the nut quite a long way up the thread. So the question now would be, do I shorten the spring a bit? I might actually not. I thought it was quite a long way up, but now I've got the pendulum out. Doesn't look too bad. And also importantly, there's still a good way to go. So it's actually about halfway up the rating thread. So I'm probably going to leave it. But if I were to shorten the spring, the beauty of how we've done this, of course, is that this pin here isn't riveted. So we can push it out, get the spring out, punch a new hole in it with our staking set, and away we go. And I'd shorten it by about 1/8 of an inch or something, or about, I don't know, 1/3 of that value there. Because remember, as you shorten the spring, it's a non-linear relationship. It's a cubed relationship. So you shorten it a bit and it actually makes a lot of difference to the restoring force. So anyway, having just got that out of the clock, I think actually we will live with it. But the good news is that it works fine. The clock is ticking away beautifully, and we're very happy with that. Okay, I'm gonna have to go shut the blind in a minute because the sun's coming in, so. We don't have the old voice activated blind closing device yet. Siri, or whatever it's called, Alexian. Okay, so our list. So a couple of weeks ago, we put on Facebook, what are the top faults that you find when you're repairing a clock? So this can be either, interesting point actually on length of the rod matters, so short the rod as it was cracked. Maybe you want to bit longer to compensate. Yeah, the length of the rod and the length of the spring are different things. I mean, obviously they're related, but the spring, the rod, the restoring force on the rod, because it has mass, is gravity, whereas the spring is a different thing. It's the spring rate of that material that adds to the value of gravity. So you've got a slightly more complicated, it's, as I said, it's not a linear relationship with the spring. You make the metal a bit thicker or a bit shorter, and it makes quite a lot of difference. Whereas with the rod and the length, it's just a square law. It's whatever it is, T equals 2 pi root L over G. So you can figure it out that way. So we talked about this before, happy to go back to it. But if you want to, like a lot of people do, they buy a clock and it hasn't got the right pendulum with it, or it hasn't got any pendulum. How long should the pendulum be, the theoretical length of that? You can do that by taking the clock apart and doing what we call a train count. So counting the teeth and the leaves on the going train wheels, mobiles. And you can do a calculation, figure out the length of the pendulum in theory, and that gives you a kind of ballpark to begin with. The spring is part of that length, but it's something slightly more complicated. We talked about it last week. Happy to go over it again in future if necessary. So yeah, if you shorten the pendulum rod, then you're going to have to lengthen the spring if that's your kind of only option, but it will change the rate in a slightly different way. Okay, so in at number 24, sorry, sorry, I can't. I should turn the chat off.
Jim says a stronger spring will change the effective length of a pendulum. The spring will also be opposed by the energy provided by the escapement impulse.
Yeah, I mean that's right. A stronger spring adds to the value of gravity effectively. So you need to make the pendulum longer, and you see this on things like drop dial clocks often, that or even on spring clocks. You know, what people call bracket clocks. The case or the case isn't kind of long enough, so you let the pendulum bob down, and you can't regulate it to run slower anymore because the restoring force of the spring. If you imagine you replace your suspension spring with a steel ruler, it's going to have a heck of a lot more restoring force than it would with a bit of steel that's like this, kind of 0.1 millimeter thick. Do you remember that old thing where you school to annoy the teachers, you used to put the ruler on the edge of the desk and go like that? Well, that demonstrates what the restoring force is. So yeah, I do agree with you. The spring is a really important part of the equation, and it's the same thing, of course, for the mainspring, not to do with timekeeping per se, but in terms of the spring force. Number 24, added by David Haggerty, chime or strike problems. Yeah, so for beginners, we suggest strongly that you begin on a clock that doesn't have any striking or chiming work. Now, what we find is that people inherit or they buy a clock with what we call 3 trains. So it's got a mechanism for the time, the hands. This is going to be more of a discussion, by the way, than the normal kind of instruction. Yeah, happy memories of annoying teachers. Well, what else are they for? So people come to the Facebook group, or they say, I've inherited this clock, or I bought it at a thrift shop or a whatever car boot sale, and can I repair it? And the answer is you can. However, we suggest that you start with what they call a timepiece clock, so the time only. When you get onto working on a clock like our live stream clock here, just happens to be at hand, you have got twice the trouble basically, and then a bit, because you've got the going train here, which you can see running away because the pallets have fallen out somewhere, and then you've got basically the same thing here. You've got another mainspring, you've got another set of gears, and you've got another form of control. So not the best place to start for a beginner. However, the question is the point is that the striking train stops the clock. You know, it's a fault with the striking train that makes the clock stop. Why would that be? Well, it's probably not the best place to demonstrate it here, but let's just take this long case clock, so sort of European 19th century tall case clock or long case clock, and you can see here that the going train, the time, the thing that makes the hands go round, and the striking train are not independent. If you think about it, the going train has to control or dictate when the striking train is released. And so that's pretty straightforward in a way. In this case, I don't know if we can get this thing off here, whatever it's called. Anyway, let's get that off. Pointy stick. So this wheel here, called the cannon wheel, is where your minute hand goes on, for instance. So that wheel goes around once an hour because it's got the minute hand on it. Minute hand goes around once an hour. Okay, that direction. So looking at it. This wheel here, in this case, has got exactly the same number of teeth on it. This is called the minute wheel, which is totally bizarre, but it is. Just got to live with that. And you can see, if we zoom in, and this is only one example, but the point is you have to be focused when you're repairing a clock, when you've got a clock with a fault, on understanding the relationship between the 2 trains. If your striking train fails, with a clock like this in particular, then you're going to be in problem, because it will almost certainly stop the clock. It's not just a striking. And let's just look at an example of that. So this wheel here rotates counterclockwise as we're looking at it. And if you have a look here, there's a little pin sticking out. And that pin, as it rotates around, lifts up this device here, which is called the lifting piece, which is fixed to this piece, which is called the warning piece. And that disappears up inside the movement. And that warning piece touches on a pin. You can just see it at the top of here there, that's fitted to this warning wheel. So already we've got kind of quite a complicated relationship between all these components and their functions. So it's really important that before you take a clock apart, and particularly something like the American clock, where it's kind of quite complicated between the plates, that you take an hour, I would say an hour for a beginner to understand the relationship between those parts, take photographs and write it down. Now, in this case, what will happen if our striking train fails? Like that, me pretending I didn't know what the name was. Right, when our striking train fails here, what happens is the going train, going as normal, tries to get the striking train running, and it might be that this part touches on that pin that I just described. If the warning wheel isn't in the right position, the phase relationship of the striking train, or maybe it does, and then the rack drops like this, and then it comes down to count the hours, and then when the rack arm pin here touches on this radial surface of the snail, then the whole thing jams and the clock stops. Now, if the safety action here is working properly, then yeah, the clock might continue to run, but it's not going to be happy. With a French clock, it probably will jam. So the point is that chime or strike problems, absolutely. If you start on a single train clock, if you're a beginner, get all that theory out of the way about the escapement and the spring and cleaning and bushing and depthing, everything that applies to every clock that's ever been made, basically. Then move on to a two-train clock, either something like this or a 20th century mantle clock or an American clock, and then move on to a three-train clock. So that would be typically a chiming clock. As I said, lots of people want to start with there. My advice is don't, because you might get demoralized. You've got dozens of parts. You've got all these relationships to sort out between the different components. And I suppose another way of looking at that point is, if you've got a clock that's stopping, you might logically think that it's the going train, something to do with the escapement or the depthing or the pendulum that's a problem, not necessarily if it's a striking clock as well. So you have to look at the whole thing. And this is a really important point. On Tuesday, I'm going to one of these kind of institution clients that I've got, and a third of my energy there is not looking at the clock at all. It's looking at the whole sort of environment, who's winding it, traffic, dust, all those kinds of things. We clocks people obviously love what goes on inside the case and the movement, but remember, it's healthy if you can to constantly step back from the thing. Otherwise, you will be looking, for instance, for a fault with a going train, and all the time it's actually a fault with a striking train that's causing the clock to stop. So really good point. That's 24. Okay.
Thank you.
Yeah.
Derek says, what about a torsion clock? With
his striking train? Derek's on the list. He's on the list twice.
Okay.
You're on the list, Derek, don't worry. You're just further up the list because you're far more popular than that one. So 23. There was actually one thing talking about striking trains that I'm going to keep this thing going actually and keep it pinned to the top of the Facebook group. But another really common fault is, let's cover two things. One is customer rings up, that clock you fixed, it struck 397 strikes in the middle of the night and woke the whole street up. What do you think of? So I'll leave that with you in the live chat. customer rings up, clock struck 397 times in the middle of the night, basically until it ran down. What is the first thing that springs to mind? Okay, so that's a little quiz for you. The other thing here is this badger called the rack arm. This is often called the rack tail. The rack tail is actually this chap down here where the spring touches, but anyway, who cares? As long as you know what we're talking about. I made a video about this, so I won't bang on about it too much, but I think often and understandably, the relationship between the pitch of the rack teeth here, the effective radius of the rack, the effective radius of the rack arm, so that's from this point to the pin, is generally not fully understood. And so people find a clock that's been worn, or another super common point, and I should be writing these down, but maybe somebody who can do Facebook can put questions on that list, can put other points on that list, is that this spring here, see this spring? This is called the rack spring. It often gets bent and broken and replaced with a spring that's too strong, a common theme. So what happens? You see this spring is a piece of uniform thickness wire, and it could like lift a tank. It's that strong. Doesn't need to be like that. All that will do is that when the rack drops, so coming up to the hour, this chap lifts that badger, which moves that puppy up, this drops back, and at 11 o'clock, it'll go with such a bang like that, that eventually the rivet here will break or it'll come loose. And so the two things begin to move apart. So what will happen, maybe to begin with, you might be lucky, and the clock just strikes more. So say at 9, it's striking 11, and so on and so forth. That's never going to repair itself. So get to understand the relationship between the pitch of the teeth, the length of the rack, or the radius of the rack, sorry, the radius of the rack arm, and the steps on the snail here. And if you get a clock that's faulty in this area, do not bend anything or file anything until you're 100% sure that that is the way to go. When I often hear, or sometimes hear, yeah, but maybe the clock's been faulty since it was made. Clocks weren't faulty when they were made. They were like either out of the factory or the clockmaker. They might not be the best design, but typically you don't have to go filing and bending things. So I would put relationship or lack of understanding of geometry of the rack, which makes people maybe get into a panic. They can't figure it out. So they think, if I just bend this or file a bit off here, it's going to be all right. It will not be all right. You'll just get yourself into a mess. So anybody got the
Wolf, but then not sure about the terminology.
Right.
Jeremy said the gathering pallet isn't dropping under the rack.
Yeah.
He's not sure about terminology.
Yeah.
And Wolfie said the striking train is failing to disengage, so something is getting stuck.
Yeah, gathering pallet, I would say. Was that Jeremy?
Yeah.
Yeah. The first thing I would look at, and typically what happens is either there's a little, and you can see it's kind of quite a long way away. If our camera will focus, yeah, maybe it won't. In this case, the square, this gathering pallet here fits on a square. As you can see, the square is incredibly worn here, sloppy. I'm holding the wheel with my finger and it can move kind of like 45 degrees. So it's totally wrecked. It's never going to work properly until it's repaired. We had exactly the same problem on our live stream clock. And sometimes this gathering pallet is held on the square just by friction, like on a French clock where it isn't even square, it's just round and it's two tapers. Sometimes there's a pin that goes through, and often it either wears, the thing gets sloppy, the pin drops out, or even the gathering pallet breaks off altogether. So yeah, if your clock just will not lock, then typically what happens, you'll typically find a fault with the gathering pallet. However, there's another thing, which is maybe what Wolfie was alluding to, that if this rack drops like this, on a lot of clocks, rack striking clocks like this one, you've got this pin here. See that pin stuck in the plate that somebody has bent back, which I don't think it should be bent back, but anyway, it's there. And what that's there for, it's called the 12 o'clock pin, and it's for obviously when the rack drops the whole way. If for any reason the rack arm can ride up onto the face of the snail, if it wasn't for that pin, then the rack would drop right out of engagement. And as you said, Chris, the clock just keeps striking and striking and striking, and it can't gather and it can't lock. So 2 things to look for there. For some reason, you often see those pins are missing. There's a hole in the plate. I'm looking for a clock. Yeah, there's a hole in the plate and the pins dropped out, and no 12 o'clock pin, so put that pin back. Question?
Derek says,
yeah.
Why have we got new names for the lifting arm and the rack?
New names, oh, just for entertainment value, because remember, this actually has got nothing to do with repairing clocks. It's all about our lovely community support group and social function that we run. So it's just a way of keeping it's been oh, it's first world problems, I'm afraid, but it's been quite a stressful week with the aforementioned daughter and aforementioned trip off to university. So we're very pleased and relieved that she's going, so slightly whatever they call it, demob happy. Yeah, so let's just go back to that with a bit more serious, just have a very quick whiz round the terminology. Now, I always say in the Facebook group, there is no wrong or right way to fix a clock. And in the same way, there's no wrong or right name for the people get really excited about the wrong or right way to make. One of us in the How to Repair Pendulum Clocks team is a linguist, and it isn't me. So we have lots of discussions about what things are called. And of course, I suppose the point of having common names, and I'm on thin ice here, is that other people understand. You know, if you say, what's the widget do, or the badger, or the puppy, or the chap, then that isn't really helpful. So what we've got here is rack, rack arm, rack post, winding arbor square, spring, rack tail, snail, hour wheel, minute wheel pinion, lifting piece, warning piece, rack hook, gathering pallet. Kind of gone around there in a little circle. So okay.
Ian says rack hook sticking and not dropping.
Yeah, the on French clocks in particular, that's another fault. Stick it on the Facebook list, please, somebody, Ian. That often not the case here. You can see that this rack hook, which I've got to just get the gathering pallet off, you can see what this does. As the rack is gathered, there's another fault. I mean, this is really cool if you are a beginner, because don't get demoralized by clocks that won't run. In fact, somewhere up the list, which we're not going to get to for a couple of weeks, is a clock that you've looked at and looked at and looked at, and it just stops and you can't get it sorted out. And the reason for that is that even on a relatively simple clock like this one, there are dozens and dozens and dozens of potential problems that can cause a clock to stop or malfunction. And often what you find, particularly on older clocks, and particularly on clocks where somebody's been more interventive with their repairs, is that you've got compounded problems. So it's not one thing. Yeah, so on French clocks in particular, I have got a movement, but it's got a dial on, is that these posts can become sticky. So the rack hook post and the rack post and the lifting piece post up here, it's exactly the same on a, yes.
So just thinking of names for parts, badger was one, puppy was another.
Ferret.
Jim suggested ferret.
Ferret's good, yeah, ferret's good. Yeah, nothing wrong with that at all. As you say, ferrets are still popular. When I did my first ever stint at the Bose Museum, I stayed in a house that kept ferrets, which was good fun. But one of them had decided to sleep in the back of the washing machine and chewed all the wiring, which is a classic kind of ferret story, so be warned. Anyway, so here's another potential fault. So those posts on French clocks, they have, like this, if you can see that there, a little tapered pin through. And when people push the pin in, they tend sometimes to overdo it, which either breaks the hole or spreads the hole or throws a burr up. And that tiny little burr on the stud prevents the rack from dropping or the rack hook from engaging. So when you take on a French clock, the rack hook off, for instance, always check that little hole there hasn't got a burr on it, because it looks tiny, but just the difference between the rack hook hanging up and it falling is tiny, 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 and that can become a problem. Here's another problem, is that when, at least in theory, this part of the rack hook here, the kind of acting face of it, the camera's a bit further away today. Anyway, the acting face of it should be part of a circumference that struck from the post. So this is basically circular now, or the working surface is circular. And if it isn't, let's do a drawing. Okay, so here's a post for our rack hook. In this case, it's got a thing like that. And let's draw a circle around here. So this circle is generated from this point here. So it's the same radius wherever you look there. That circle forms the working surface of the rack hook. Okay, that's really important. And again, let's have a look. Let's draw in some teeth like this. So there's our rack teeth. Okay, so what happens? Clocks, brand new, no sweat there. This is part of that circle. 150 years goes by and this wears away in here. So I talked about this a lot and banged on a lot about pallets. Don't polish out that wear, because it might kind of look better and make you feel better, but all that will happen, let's just do a kind of zoomed in version of this. So on that surface, oops.
Derek said he has that problem on a German Westminster burr on a rack pin.
Yeah, burrs are these tiny bits of metal that get thrown up. Sometimes they're there from manufacturing. They'll come back onto burrs when it comes to bushing. But again, you've really got to, there's this thing that I used to joke with my students about: get a bit of fruit, like a melon or a lemon or a banana or any old thing. It can be anything. And just like put it in the mid distance and stare at it. And that's the kind of focus that you need if you get a fault. If you see or think you've seen a fault, chances are it won't disappear. What typically happens is you think, oh, was that rack hook hanging up? Maybe it didn't strike the right number. Investigate it now, because you'll take the clock back to your client. 3 weeks will go by and they'll ring up and say that clock stopped or it's not striking correctly or something. I had it, even I had it this week. When I test a long case clock, I try and always test it in the case. You know, I'm not a fan of test stands, but it's sometimes not possible to lug these long case clocks about. It's whatever. So I didn't test the clock in the case. So when I put new lines on a long case clock, tall case clock, I leave them long, because you don't know how tall the case is until you take it to the client's house. So take it there, set it up, no problem. And what I normally like to do is to cut the line to length. So when the clock runs down and stops, if they go on holiday or something, the weight can't fall over, the line can't unship from the barrel, and when they wind it up again, it's fine. And in this case, I didn't do that. I did shorten the line, but I thought it'll be fine. And of course, it's not fine. Again, about 4 or 5 months have gone by. It's been locked down, so nobody's been on holiday. The clients went on a holiday, they came back, they wound the clock up, and of course the line shipped off the pulley because the weight had fallen over, and then I've got to go back, and luckily I'm going back anyway, and they were cool about it. But a fault will not evaporate. Clocks, unfortunately, are not self-healing. Okay, so to back onto this problem with the rack hook, the thing wears like this. So if you kind of polish that out to make it look nicer, what you've got there is the tendency for the rack to push the rack hook out of engagement. So if we go back to our clock here, if this surface here isn't part of that circumference, and the rack gathering pallet whizzing round, touches on there, when it's particularly worn, what you can find is it pushes the rack hook back out of engagement. And that can be another reason why the clock just continues to strike. And conversely, if there's kind of draw on this, so if when you lift the rack hook, and here it's actually quite neutral, there's a little bit of sort of impulse there. But actually, if you find this draw, if it's pushing the rack back in this direction, this way, and the rack spring is too strong, it might stop the clock because the clock can't release the rack. So again, even in that one relatively simple looking component, the rack hook, there are many, many things that can cause you a problem. Okay, so that was 24 problems with striking. We'll come back to them because there are many problems with striking. So 23, unable to rate the clock due to the rating thread nut strip sticky damage. Okay, this is another one of my many dozens of clocks not self-healing. Work on them, press if they were. Yeah, the reason why I've got my gloves on from the beginning today is because I've been working on the railings restoration project and I painted them without my gloves on, so my hands are covered in zinc paint. Right, okay, so you may or may not remember from the live stream clock that when I fix the clock, at least in theory, of course I'm a hypocrite, so I don't normally do it this way, but I like to do all the stuff around the clock first before I get to the movement. So when I put it back together, it's done, because there's a big difference. And again, I won't mention test stands, but there's a world of difference between a movement ticking away on a test stand and it actually in the case, the key's done, the pendulum's done, the rating sheet's done, the report's done. They are totally different things. So what I used to find myself and with when I used to teach is that you get the clock ready to go to the client, yeah, everything's done. Wait a minute, the client can't regulate the clock, that we haven't dealt with the pendulum or the rating nut. So I'll just find so this is actually a new pendulum bob that one of my students made on a clock that I'd bought. And what you can see here is the bob can slide up on, do you like the scraping, by the way? Isn't that really cool? Anyway, first year student project. I think it's really nice. So, sorry? Yeah, scraping with a file scraper is really...
It's problem number 22. Where's Harriet spelled?
It's on top of your computer.
Thank you.
So yeah, what happens is that the oil from the crutch, which is kind of all the way across here somewhere, over decades and years and years and years, drips down off from the movement and gets inside here, or people maybe even oil inside here. The oil goes sticky and you can't regulate the clock because the bob won't slide up and down, or the pendulum's been dropped and the rating thread is bent over, or the thread is stripped, or it's seized up. So my advice is when you repair a clock with a pendulum, just make sure that your client can repair the clock. Typically, what happens is you can, with brute force, often on old clocks as well, I don't have one here, they need a bit of a washer or a spacing piece here to actually, so you can actually grip it. Remember, a lot of my clients are sort of older people, and regulating a clock anyway is quite tricky. Sorry, we just got a bit of a domestic situation here, so we just might have a half a comfort break.
It's not.
It's downstairs somewhere. Time for a very short comfort break. 2 minutes, back in 2 minutes. Okay, sorry. There we go. 1 week and counting. Okay, right. Don't lose the gathering palette there. So yeah, to check that you can actually regulate the clock. As I said, you know, for us, we say we've regulated this clock and it'll be fine. You might need to kind of do a bit more regulation, and it's nice to demonstrate, but make it easy for your customer, because what tends to happen is that if you don't do that, you can brute force the bob upwards with the thread here, which of course doesn't do the thread any good, but then it's sticky. So the client starts letting the nut down, letting the nut down, letting the nut down. Then it either goes like this and damages something, or it just stays there, and so the clock's gaining. I can't get it to lose time. Anyway, banged on about that. So there you go.
Wolfie says there's a lovely sticky patch on the section of the pendulum rod where the bob sits on his C7.
Yeah, there always is. You get that oil that's just kind of neither solid nor liquid, green. It turns green inside there. And yeah, just take the pendulum apart. I think it's one of the first things I do, because as in terms of the approach as well to a repair, I like to sort of generate a bit of time where I kind of circle around the actual repair. So you can do that by vacuuming out the case, doing things like the winding key, check the winding key's a good fit. If not, make a new one that fits. And then you're into the repair rather than going straight in. Because the problem with that is it's so easy to lose objectivity.
Ian says sometimes the shell of the bob is damaged at the bottom and a washer can help the nut work better.
Yeah, 100%. That's absolutely right. I don't have a long case bob here. I've got plenty around. But often if the suspension spring breaks or somebody's been trying to fit the clock together, falls on the floor, this one is a bit like that. Look, it's dinged in. And yeah, you often find that it actually pushes the nut inside the shell. Now, that's quite a tricky thing to resolve. And you can sometimes get a boxwood mallet and hammer this back a little bit, but it's quite tricky to straighten it up fully. So the best thing to do, as Ian says, absolutely right, make a spacing piece that separates the rating thread from the bob. So just a little bit like that, 1/8 of an inch on a long case, tall case clock. And it just means you can easily regulate the clock. But absolutely, really good point.
Derek says the green is the oil reacting with the brass.
Yeah, I suppose it's some copper thing. Is it some copper corrosion product? But yeah, the oil turns acid and it goes green, and it goes all sticky. Okay, 23.
Just before you go on to that,
yeah.
James says about the test stand. Clock cases don't always make great test stands, as you can't always see things without taking the movement out.
No, that's the whole point. The point is, I mean, I do get, sorry, I mustn't get drawn into the test stand thing, and I'm partly joking, but I do get the fact that a lot of people just like to see the mechanism working, but I think for me anyway, I kind of have two sides to my horological life. One is doing this, which I really love, and you know, it's just all great fun. But the other one is a kind of slightly more commercial, using the term slightly jokingly, but approach. And my sort of mindset is and it's easier for me, obviously, relatively, because I've been doing it quite a long time. And it isn't that I don't get faults, but I'd rather go through the whole thing and think it's going to be fine. It's going to be 100%. I'll sort out all the problems, stick it in the case, put it on test, off it goes. And if I get a fault, yeah, I've got to take the movement out again. I just think the test stand thing is a habit. I can see why people, my co-author, John, with the book, he always puts clocks on test stands because he said he loves to sit there and watch it ticking. And I say, yeah, gathering dust, and also getting knocked over by the cat, and etc., etc. So I do get that, particularly for a beginner, a test stand is a really useful thing. For me, it just introduces more problems than it resolves, is my kind of defense. 20, any other?
Yes.
Oh.
Wolfie says that John deserves at least some pleasures since you stole his vice.
Yes, exactly. Yeah, it is. I think Chris Wolfe knows this story as well, but there's one of the best collections in the country. There's a kind of anecdotal line about that collector. Why did you collect? And he said, well, I just like to watch the wheels going round. So I totally get that thing about having the movement on the stand and looking back and saying, you know, I've got this clock working, which is a really good thing. My perspective is slightly different because it's just caused me a lot of pain in the past of a clock is not finished when it's on the test stand ticking away. It's finished when it's on the client's wall and they've paid your invoice and they've sent you a little email that says, we're really happy. That's what I call finished. Anyway, so Greta Cobbs in wheel teeth. Nobody seemed to like voting for this, or one person did. It's the drying media that I use. You just got to be thorough about making sure that it's all out of the teeth. And I think I'm particularly sensitive again to this because I had a particular job which was a regulator. So it had very fine teeth. It was a solar sidereal regulator, incredibly fine teeth. And I made at least 2 400-mile round trips to sort out a problem with this. And I went through everything. It drove me crazy. And what I eventually found was there was a micro bit of the drying media in the root of one of the teeth. And the wheel was going round and round and round and round. And just every so often, it would stop the clock. Eventually, on the 3rd visit, I flicked it out and it's been absolutely fine ever since. So yeah, that was a bit of a personal story, really. Okay, well, this is totally out of my, how are we doing for time, by the way?
48.
All right, okay. So this is totally out of my zone because I don't know anything about torsion pendulum clocks, but we know that Derek does. Although he kindly sent one, which we're going to do a live stream on in a bit. But suspension spring replacement on a 400-day clock. We talked last week about the suspension spring replacement on a fusee clock. We've talked about it on a long case clock on the live stream. On a 400-day clock, my view, and it might be wrong because I don't have that much experience in them, is I would always just buy the unit that you get from Horolovar, is it called? Make sure that it fits the right clock and just go with that with the blocks and the fork. So a suspension spring for a 400-day clock has got 4 primary elements. It's got the spring, it's got from which the pendulum rotates. It's got a bottom block, a top block, and then a fork that engages with part of the pallets. And the relationship between the distances between those 3 components and the thickness of the spring are really critical on 400-day clocks. So I would say buy the unit, but Derek, what do you say? Do you, I know it's a more expensive way of doing it, but would you advise people in this group to get the spring and put the blocks on, or would you advise them to get a unit? So what does Derek say? I'll answer that. So while Derek's answering that question, spring and blocks or unit, and other people chip in by all means, what do you do in that case? I've never not just bought a unit and put that on, and so far I don't do many. I've maybe only repaired 6 in my whole life. So
spring and blocks or unit.
Yeah.
Okay.
Yeah. Okay. So we'll come back to that, but and in fact we've got that again later on. So number 20, this is like everybody's kind of worst thing is you've repaired a clock, you've put it on your test stand, you put it back in the case, it stops. Take it out again, you look at it, you go through it, it stops, it drives you crazy, you want to chuck it out the window. And maybe you've got a client who was on the phone saying, have you fixed my clock yet? And you cannot figure out what the heck is wrong. Okay, I've got no idea other than I've got a lot of ideas. So first kind of places you look. And this is kind of related to that story that we get a lot on Facebook, which is great. I don't know anything about clock repairing. I bought a clock at auction or whatever. I've stuck it on the wall. It's not working. Where do you begin? So here, this is where you begin with this top 20 list of faults, basically. With a pendulum clock, really important, I would say the first thing is that the clock is fixed to the wall. Long case clock, fixed to the wall, not on a carpet. Mantle clock, we saw it with our, where's it gone? Oh, it's disappeared now. With our live stream clock, the American clock, that the 4 feet are not flat, so it rocks. The case for a pendulum clock must be fixed and firm, not on a little wobbly side table, not on an Axminster carpet, but fixed to the Rock of Gibraltar. That's number one thing I would say. And then it's obviously easier to go from the outside in. So looking at the blindingly obvious, like lines, like I was talking about before, that are maybe tangled, hands that are touching the inside of the glass, more of an issue on a watch, hands that are touching the dial, and then the dial comes off, motion work, striking work, that comes off. Suspension spring, pendulum, is the pendulum touching the case. So you're working slowly towards the inside of the movement. And presumably if you've already repaired that, the one sort of like klaxon sounding, red light flashing type scenario for me is if I see two things actually. One, a clock that's been extensively refinished through use of chemical or ultrasonic cleaning. That I find disturbing. I've seen it twice this week, and it means to me, right, we've got a significant problem here, not least of which is that if the clock has been etched through refinishing, then all the teeth, the wheel teeth, are going to have a sort of open etch surface which needs to burnish and that kind of thing. So that's one problem. But the other thing that actually is sort of massively problematic is if I see a lot of bushing that's been done. And there's nothing wrong with bushing, and I again get on my soapbox here, but bushing without depthing makes no sense. It can often cause more problems, and we're going to get onto that here. So those simple things like clock case fixed to the wall, right through to problems with bushing and depthing, mainspring replacement, and so on. Experience, I would say, but I think this here, clock stops when disassembled a few times and examined. It's tricky. Clock fixing is not simple or a straightforward thing to resolve. Experience, of course, is great. Our Facebook group is brilliant because it supports people there, but it can be from, and this isn't to put people off, a tiny burr on a stud through to the wrong mainspring, through to poor depthing, through to escapement issues, through to, you might get something like, you take the whole thing apart, you do everything you can imagine. Somebody's put a new mainspring in and it's 0.25 of a millimeter too high, and it's just rubbing on the inside of the barrel cap. I've had this many times, and you think, so you take the barrel cap off by banging it down on the bench, which is a quick way to pop off the cap, and then you think, looks fine, spring looks fine, nothing wrong there, put it back on, put the clock together. But as the spring is wound and it moves towards the arbor, and maybe the cap, the distance is a fractionally less there, the spring binds, and you can't see, because when you take it apart, it's not obvious until you look at the inside of the cap and you see some rubbing marks and you think, all right, okay, maybe this is it. So hopefully this is helpful there. And I think the answer here is, I've heard people say the clock's never been right since it was new. I don't actually believe that. Well, whether it's viable or within our capability to fix it is a different thing. You know, if you've got really worn pinions in a 17th century clock, you might want to laser weld them, you might want to make new pinions. It might be that the object is effectively a relic and it can't be repaired in terms of time or money or whatever. But typically we can get them going.
I think
Derek's
answered your question.
Right.
He never buys complete units because he likes to use the original blocks and forks if he has them for originality, and there are so many different blocks and forks.
Yeah. That's a nice point. So the answer from Derek, who's our in-house torsion pendulum expert, is that he keeps the blocks and forks and fits the new spring for really good reasons, that they are part of the integrity of the object. And if they're the original blocks and forks, then why not transfer them across? And again, I think, Derek, you look in the book, the Horolovar book, because it's got pictures of the distances and you set them on top of that. I think that's how it's done. Great. Okay, thank you, Derek. Brilliant. So
Wolfie's got a nice story about a clock that was sold by Carter Marsh. It was regulated by one of the elders of the Bullamy clan with a visual set of instructions.
All right, nice.
Specified fits into the wall and having the feet hover a quarter of an inch off the floor.
Yeah. Yeah, in the that's a really nice story. So regulators where the whole thing is bolted to the wall in the probably, I'll get this right, towards the end of the 18th century. I think there's a story, again, it's at Belmont House story of somebody walking into a room and seeing this regulator kind of swinging about, and like, no wonder it's not ever worked. George Airy's got similar stories about clocks with sympathetic action. So they started to take the, like on our clocks, our domestic clocks, the pendulum hangs from the movement from the back cock or the pendulum support. In regulators, they do away with that and they fix the pendulum support not to the case, but directly to the wall. One of the best examples of that is the sidereal standard Dent 1906, which the bronze casting is about 35 kilos. It's a whopping great big bit of metal to get around the fact that the case must be fixed to the wall. And again, another, anecdotes, transit Venus story. So this was going all around the world in the 19th century and 18th century as well, putting up temporary observatories. You've got no walls, you've got no buildings in the middle of nowhere. Chop the tree down to about 6 foot high, and that makes a really great test stand that can't wobble. Okay, number 19 is frightened off by Matthew's safety costume. So yeah, it looks grim. Sometimes you feel stupid. You put on the goggles, which have been borrowed for the railings project, and you put on your visor. I saw actually in Jeff Allnutt's Twitter feed the other day, one of his apprentices, he's a watch guy down in Sussex, runs a great little organization down there, and one of his students, an apprentice, was doing some tool grinding and they were using a full face visor, and I thought, thank goodness they're really taking that seriously. A visor actually is often better than a pair of goggles because it doesn't steam up, especially if you're wearing glasses. So yeah, gloves, visor, eye protection if you're using machine tools.
It's 58.
Right.
59.
Okay. So we've got to do the mainspring thing. So that's how far we got today. Okay. So let's get the hat for the mainspring draw. Thank you, Team Welcome Clock Club, for reminding me because I would have forgot. So where's the mainspring winder? So here's the mainspring winder. It's got a couple of arbors with it. You might have to make some more arbors, but it's there and it's in good condition. Right, shall I?
Yeah.
Mix. Thank you. So here's the hat. So here we go. So you can see. There we go. One. So the mainspring winder is going to Tom Stevens. So Tom, if you're there, presumably you're there tonight, wherever Tom is, drop us a line in a message or send us an email or something with your address and we will get this in the post. So thanks very much to the donor of the mainspring winder, very much appreciated. And thank you to everybody who, I'll leave Tom's name out, then we won't lose it. Everybody who went to the competition. Great. So we are out of time and we've covered 5 of our faults. We'll continue next week with number 18, which is again another one that I learned through some incredibly painful and embarrassing experience of one of those, like, there are clocks that just run and they're brilliant. Obviously there are clocks that just stop, and that's kind of all right because at least you can do the staring at a grapefruit thing and figure it out. But the biggest problem, of course, is intermittent faults. So you test the clock, it looks fine, you send it back, it stops. You look at it, you just can't figure it out because it doesn't do that fault the whole time. And this is one of them, the cannon wheel or star wheel touching the back of the hour wheel bridge because of a problem with the taper pin that holds the hand on. Anyway, we'll cover that next week. In the meantime, massive thank you to Team Open Clock Club for keeping the live chat going. Thank you to everybody who's been chatting and turned up. Again, super big thank you to everybody on Facebook. Please, if you've got a clock on the bench or a tool or a process, if you can, just take that extra 5 minutes to take some photos, stick them on Facebook with a bit of a description of what you're doing, because it's that stuff. We love to see projects that are done, but that isn't massively, it's an encouragement, but it's not massively instructive for our beginners. But what is really instructive is I saw this thing, I tackled it this way, and that really helps. So thank you. We'll be back on Thursday, I think, this week, yeah, with our American clock. We've mucked about with a case, and we're going to be putting our homemade spring clamps on wherever they are. I've lost those as well, and actually getting that apart and looking a bit more at that deadbeat escapement. So thanks very much. Have a great weekend, everybody, and we will see you very soon. Thank you. Bye for now.